A very good evening to one and all. Welcome you all to the day 3 of the Faculty Development Program on Advanced Computing and its application trends. Now I would like to call upon Mr. B. Prashant to introduce the session speaker.
Good evening, everyone. It's my immense pleasure to introduce our resource person, Dr. Pergu Shyam. He is a distinguished academic and researcher specializing in bioinformatics and cancer biology. With a career spanning over a decade, his contributions have significantly advanced the fields of computational biology, biomedical informatics, and public health nutrition in India. Dr. Shyam began his academic journey as an assistant professor at Jawaharlal Nehru Technological University, Hyderabad, where he played a pivotal role in establishing the Department of Bioinformatics. He later joined the Indian Council of Medical Research, National Institute of Nutrition as a scientist, where he led multiple national level initiatives in nutritional science, health informatics. Notably, he led the development of several impactful digital tools, including Nutrition Atlas, Count What You Eat, Foodborne Disease Surveillance Portal. He also developed the molecular property diagnostic suite and a range of other computational platforms which were funded by the Government of India and officially launched by the Union Health Ministry. In 2018, Dr. Shyam joined the National Institute of Technology, Warangal, as an assistant professor in the Department of Biotechnology. He has mentored numerous research scholars, successfully guided 2 PhD candidates, and currently supervising 3 more. Dr. Shyam has published over 62 research articles in reputed international journals, holds 2 patents, and has secured multiple research grants from premier funding bodies. His current research interests include computational biology, machine learning in biomedical research, computer-aided molecular design, chemoinformatics. He is particularly recognized for his work on non-covalent drug interactions and the development of computational models. In recognition of his innovative work and multidisciplinary expertise, Dr. Pergu Shyam continues to be a leading voice in India's scientific and technological advancements. Thank you. Now, I hand over the session to Shyam sir.
Thank you, madam. Thank you for a brief introduction. So first of all, I would like to thank the organizers for giving the opportunity to speak in the ATAL FDP program. Thank the management for the Siddhartha Engineering College. Am I audible?
Yes, sir, you are audible.
So can you see my PPT, madam? Is it visible?
No, sir, it's not visible. Wait a minute, sir. I'll stop sharing my screen. Yeah, now it's visible, sir.
Okay. So, very good evening, participants, for the third day faculty training program. So, today I'm going to speak on quantum computing and its applications, or the basic introduction to the various applications of the quantum computing. So, the word is today we are hearing that is a new, but it is not a new. It's a old concept. It's a technology is old, but earlier we didn't use. So that is the reason we are little bit tense and little bit worried about, oh, this is a new technology, we need to adopt it. So yes, we need to adopt it whenever the new technology, new methods has come. So definitely we need to adopt it. So then we'll see the elaboratively what the quantum computing and its applications. When I say the quantum computing is a multidisciplinary field. So when I say the multidisciplinary field, it is associated with the various branches, various disciplines. So what are the major disciplines this is associated with quantum? So quantum, when I say the quantum is a physics approach. Quantum is dealing with the mathematics. Quantum is dealing with the computer science. So quantum computing is a multidisciplinary field comprising the computer science, physics, mathematics. So whatever the physics, whatever the mathematics, whatever the computations you have, that we are using the mechanics to solve the various problems. So various problems we have in a different disciplines. The disciplines problems we have to solve it in a faster manner. Earlier, some of the computations are doing, but we wanted to do it very fast rather than the existed tools, existed computations. So that is, whatever the problems, whatever the complex type of the problems you have to solve the faster the classical computers to do. That is a quantum computing. So when quantum computing is there,
Excuse me, sir.
the field of the quantum computing.
Excuse me, sir. Sir, some of the participants are saying your voice is a bit low, sir.
Oh,
Can you speak to a bit closer?
now it's okay.
Yes, sir. It's fine.
So the quantum computing includes, or quantum computing is an interdisciplinary or multidisciplinary field. This is associated with the physics, mathematics, and computer science. When it is integrated with the various branches, so this utilizes or uses the quantum mechanics to solve and to address the various complex problems that are different domains, the faster than the existed computations. Whatever the computations which we are using, whatever the tools which we are using, whatever the programming which we are being used, this quantum computing is fast performance than the existed scenario. So when I talk about the quantum computing includes hardware research and application development. You have to develop some of the applications, and it includes the hardware research because you need a infrastructure, you need a architecture. So whenever you are talking about the architecture, so that is called hardware. So as of now, we don't have. So we have to establish, we need to establish the architecture, we need to develop the silicon chips, we need to develop the different types of the hard disks and motherboards and silicon chips, etc. Then quantum computers, what we are speaking, are able to solve various type of the problems that are the faster than the classical computers or traditional computers by taking an advantage of the quantum mechanical effects such as superposition and quantum interference.
Sir,
What do you mean the superposition? What do you mean the interference? The
sir,
quantum
some of them are saying
hello.
sir, some of them are saying voice still.
Hello.
Sir, am I audible?
Still you are getting the not
Yes,
clear?
sir. Yes, sir. In the chat box, they are leaving the message that your voice is still low, sir.
Still no. Okay.
It's fine for my answer, but many of them are saying that they are not able to listen.
Sir, if you are able to listen, the same voice will goes to the everyone, right?
Maybe my laptop's volume is a bit high.
So ask them to check their speakers volume or
Yes,
headphones
sir.
volume.
Yes, sir. Yes, sir. Sure, sir.
Just
You
ask,
can.
check and let me know. So
Yeah.
then,
Okay, sir. They're leaving the comments in the message box in the chat box, sir.
yeah, just seeing. Voice is very low. So itna speed I am speaking, itna loud I am speaking.
Yes, sir. Or else, can you make the mic a bit closer, sir?
So audience, please try to check your volumes or your headsets or your volume in the computers or desktops. or laptops, can you increase the volume? As I'm speaking in the very base levels and echo is coming in my room. Shall I proceed?
Yes, sir, you can, sir.
So this quantum computing deals with majorly falls under the superposition and interference. So that we will discuss in the upcoming slides. So whenever the quantum computing or any computations that are there, so somewhere it will be used. So now the AI/ML is ruling the software sector or all the sectors. So it the quantum computing also boost the speed of the processes and the boosting the machine learning algorithms, various optimization procedures that includes automation, that includes the physics, that includes the computer science, that includes the chemistry, that includes the biology, that includes the mechanical, that includes the industry optimizations and various simulations, various trajectory generations. So we used to use these quantum simulations and quantum computing approaches. Then when you look at the quantum computing leverages the principles of the quantum mechanics to solve certain types of the complex problems when and where it exists the multiple states in the simultaneously. So that whenever you have a multiple problems or multiple states, you need to address in a parallel manner or simultaneously. So that is called superposition. And you need to address each and every problem or each and every task that is called entangles with each other. So look at here in the picture. So you have a qubits. The qubits will runs with the zeros and ones have more. So this qubits multiple states wherever you have, so that can works in a 360 degrees rotations. Then, so the qubits has a potential capability in various sectors in the material science, drug discovery, the financial modeling. The financial modeling is like your forecasting and predictions of the NSE, Nifty, and BSC, and breaking the current encryption or cryptography methods. So, how this quantum computing will work? The quantum computing, works normally zeros and ones. Your classical computers also works a bit. Classical bit can only take one of two values, either 0 or 1. When it comes to the quantum computing, it is treated as a quantum bit. The quantum bit is called as qubit. The quantum bit is called as a qubit. This qubit can also be found in a superposition of either 0, either 1. So 0 and 1 states. So you have a 0 and 1 states. So the both superposition of a 0 and 1s will be taken in a quantum computing. So this is disturbing me now. Yes. So then essentially the 0 and 1 the same time until a measurement is made. Whatever the purpose you are doing, so that measurement, that thing has to be complete till that time the qubits will work. So one of the important aspect in the quantum computing it measurement processes is that it alters the state of the reaction, state of the qubit. The qubit works 0 and 1s or both. So whenever you have that 0 and 1 or both, so the effect of the measurement is that the new state is exactly the outcome of the measurement. Whatever we are assumed, whatever we are intended, that measurements will come based on your assumption. Moreover, whatever the quantum mechanics we have, so we can specifically check the properties of entanglement. We will exploit the properties of the entanglements. So one way we are intended to produce the entanglements. So this process is two qubits closer. Whenever it comes to the closer together, they performs an operation. That operation to entangle them, and they move apart from again. So whenever you have the entangles are there, the entangles can move from arbitrarily from anode to cathode, cathode to the anode, or electron to proton, proton to neutron. So when you take the neutron concept, so the neutron containing electron, protons, and neutrons. So this has to roam one surrounded by the another, another surrounded by the another. So this is also the arbitrarily apart from the each of the other, they remain entangled. So this entanglement is the main phase itself. It outcomes the measurements of the other qubits. So whenever your qubits as 0 and 1, so they are works when your expected outcome will comes. Till that time, your qubits will work in the same notation. The quantum computing promises to solve the problems that are impossible for the today's computations. Today we have Intel 9 processors, quadra-core processors, octa-core processors. Then you have a distributed computing, you have a parallel computing, you have EA workstations. But these are not solving our problems. This quantum computing promises to solve the problems that are impossible by the today's computers, including the problems in the cryptography, finance forecasting, weather forecasting, and drug design and drug discovery, and data analysis. So we are producing the enormous data. The enormous data, whatever we are generating, we are not in a position to analyze because we don't have that much of the manpower. We have algorithms, we have programs, but the analysts are required. So there are the problems. Today's computers, today's algorithms are not sufficient to address the existed problems to address. Then, by leveraging the quantum properties of individual atoms and elementary particles, leveraging the quantum properties of individual atoms and elementary particles, so these computers can store and manipulate the information in a fundamentally different way from a classical computers. Whatever the computers which we are talking, these classical computers or the elementary particles, these can store and manipulate the information in a fundamental levels. So whenever you are at a fundamental levels, these classical computers opening the door to a new algorithms and new solutions because advanced level you require. So when you look at here, the quantum computing, the approach, like normally we have a quantum chemistry, quantum physics, classical physics and classical chemistry, classical mechanics and quantum mechanics. So here, in the 1980, the first quantum mechanical model of computer using the Schrodinger equation to describe the quantum tuning machines that are called QTMs. In the 1980s itself, the Schrodinger equation was described in quantum mechanical systems. Later, the Heisenberg uncertainty principle is described. Then you have in the 1985, in a 5 years interval, the first universal computer with a quantum is described. The first universal quantum computer is described, that is called classical counterpart. Classical counterpart in universal tuning machine. That is universal tuning machine. In the 1985, they were developed. So in the span of the 10 years, 1994 and 96, the interventions of a quantum algorithms, there are the interventions in the quantum algorithms, the quantum databases and search algorithms are developed, and that are the first quantum error correcting codes are developed. From them, so we are using the quantum approaches. But the problem has come, the architecture, computations. Then 1998, the quantum computing systems in qubits produced by IBM, Oxford, and MIT. Today, the Amazon also. So, but most of the time, some minutes, every 30 minutes access is given by the IBM for usage of the qubits. So, this is the produced by the Quantum and Oxford University and MIT University. In the 2001, the experimentally factoring the 5-qubit quantum computer in the IBM. So IBM is continuously doing the research in the quantum area. So then in a span of a 10 years or 15 years gap, the 2015 and 17, so IBM makes a new quantum computing becomes available on the IBM cloud for academicians and researchers. IBM made it available for the academicians to use the quantum computing facility in the cloud. When that is 17 and 18. Then in the 19, IBM launches the integrated system for the quantum computing for scientists and businessmen. Now they have expanded from the researchers to the businessmen to usage of the quantum computing facilities. Then in the 2020s, the quantum computer architecture is developed. This architecture is based on the trapped ion, that is called QCDD. That is QCDD is nothing but a quantum charge coupled device. The quantum charge coupled devices are developed, and that quantum charge coupled devices which we are using for a minute-to-minute basis. If you want to use more computations, you need to pay to the IBM. So this is a historical background of the how the IBM is, how the quantum computations and quantum technologies or quantum tuning machine to the current, the quantum charge coupled devices are developed in the sector there. Now, so what is a quantum? Sir, someone is scrolling the cursor here and there. So whatever the qubits which we have, the qubits are the building blocks of the quantum computing. The qubits which we use in a quantum computing. So qubits are a quantum. Qubits are quantum information that carries and carriers of the information that exploit the quantum mechanics to process the information in ways impossible for the classical computers. The qubits are quantum information, the carriers that exploit the quantum mechanics to process the information the ways impossible for the classical computers. That is the quantum computations. The qubits has that much capability. So a qubit, it's a short for the quantum bit. Qubit is a short for the quantum bit. So qubit is the basic unit of information in quantum computing. It is similar to how a bit is the basic unit in the classical computing. So whenever you look at the classical computing, it uses the bits or binary digits, 0 or 1. But quantum computing, it's a qubit. Qubit can be 0, 1 or both. Whenever I say the both, it is called superposition of 0 and 1 at the same time. So that is a qubit. That is a quantum computing. So when you look at the classical bits and quantum bits, classical bits, we used to say the classical computing, quantum bits is called as the quantum computing bits. So in the classical computing, it can exist only two states, either 0 or 1. When it comes to the quantum bit, quantum computing, it can exist in 0, 1 or a superposition of a both. That means 0 and 1. When it comes to the quantum computing, classical computing, it represented as the switches. That is either on and off or true or false. That are called switches. When it comes to the quantum computing, it enables the parallel computations. The parallelly, it will work in the superposition manner. So in the classical computing, it is a deterministic behavior. You need to determine. Based on that, it will work. But quantum computing, it governed by the quantum mechanics, quantum simulations, right? Then, so what is the qubit? How it looks like? You look at here the qubit. The qubit is a state of the, it's like a globe-like nature. It is a unit of a sphere which has the both poles, that is north and south poles. You have x-axis and y-axis, z-axis, because it is a three-dimensional qubit. So x-axis, y-axis, z-axis will be there. So it is a pi and psi. The dipole moment, the 180 degrees of the one axis, another axis, it will be measured. So that is a plus 180 minus 180, or you can measure the 360 degrees. Okay. So with the sphere of north and south poles or zones, the north and south poles that are corresponding to the two states, 0 and 1 of the classical bit. 0 and 1 of the classical bit. Whatever the space we have, the space of 3 qubits is a 2 to the 4 of whatever the qubits you have. So this is north and south will be measured. So this is 1 bit and this is a 0. 0 and 1 here bits, but here you have a qubits. At a time you have a 0 and 1s. This is called 2 to the 4 of 3-dimensional complex vector. So this is called, wherever you have a x-axis, y-axis, z-axis, that are called the space of the 3 qubits is, you have a 3 qubits, but you have a 0 and 1. So 0 and 1 is a 2. 3 such space, that is a 2 to the power of 3 dimensional complex vector will be used in quantum computing. Some of the main components are key principles or properties of a qubit. Qubit, whenever you have a 0 and 1, it is the superposition. So the superposition is, someone can approve it. Okay. Let me talk. Okay. So the superposition, a qubit can exist in multiple states, 0 and 1 at the same time. Same time, 0 and 1 can exist in a various states. So this 0 and 1 allows the quantum computers to process many possibilities in a parallel manner. That is called simultaneous. Simultaneously, we will allow the quantum computers to process many possibilities. Think of flipping a coin. That is spinning in the air. So you are throwing the coin in air, that is a spinning. So north to south. It's a both heads and tails until it lands. We don't know whether head comes or tail comes. So when it is there in the air. So that is the superposition. Then you have the another operators. When you are tossing a coin, head may come or tail may come. So that is a 50% probability is there, right? So similarly, so that we can set the superposition as an example. When you look at here, the entanglement. So the entanglement is like a elastic nature. Entanglement is like a entanglement, like it's a spring-like nature or zigzag nature. So that are linked together. So the qubits linked together no matter how far apart. So changing one qubit instantly that affects the other. Changing the one qubit instantly that affects the other. So it provides the faster communication and coordination between the qubits, like twins who sense each other's feelings when apart. You are a twins. You have a twins in the family. Both looks like identically same, but functionally their feelings, their emotions may be differs, but linking is there. Okay, the linking is there, a connection is there, that are the identity in a appearance. So the entanglement is you are intacted to the some of the other component, that is called linked together. So that is an entanglement. So the final one, the third one is called interference. The third one in the quantum computing is called quantum interference. The quantum interference, the quantum computers use interference to amplify, connect the answers, and cancel out the wrong ones. Whatever it is there, whatever the waves, whatever the frictions that are coming, someone is interfering. If you and me speaking, someone will come and interferes, then we will remove. The quantum computers use interference to amplify the correct answers and cancel out the wrong ones. We both having a conversation. Why the other one is there? So others' voice, others' answers will be cut down. So the conversation between you and me only will be taken. So like that, it amplifies the correct answers and wrong answers will be removed. So it ensures the higher level of the accuracy and efficiency. Higher accuracy, higher efficiency in solving the complex problems. For example, you have a VLC media player, MP3 media players, or so many media players are there. The musical notes, the tuning of the musical notes, right harmonic can be here. Sir, someone is writing here, sir. Hello. The organizers.
Sir, just a minute, sir. I'll be checking the settings.
No, someone is doing the cursor handling and
Yes, sir. Yes, sir. I'll check it, sir. I'll take care of it. You can continue, sir. I'll just change the settings.
So it ensures the tuning of the musical notes. So only the right harmonic can be recorded, right harmonic can be here. So right, so that is called quantum interference. The main concepts here: superposition, entanglement, and quantum interference. So these are the three properties. These are the three properties that are there to the qubits. So because of these three properties, the qubits work like anything. So the qubits are having a faster performance with these three properties. So when you compare with the classical computing and quantum computing, whenever you look at the basic aspect, the classical computing use bits 0 and 1, 0 or 1. Quantum computing uses the qubits that are 0 and 1 at the same time. So processing, it's a sequential processing. We used to write a sequential programming, but we have an advanced parallel programming also, message passing interface also. But that are not a regular. So few people's advanced computing persons only will use. But here the quantum computing by default, it will works the parallel computing, that is called many possibilities at a one place. So by default, it's a parallel computing. So power growth, it's a linear with the more bits. It is a exponential with the more qubits. So it is a quantum computing is classical computing is a best for everyday tasks and predictable systems. But quantum computing is a complex problems. It is not for a sequential problem. It is not for a traditional problems. It is for complex problems. It is a complex optimization purposes and your artificial intelligence computations and your cryptography issues. So that purpose we use to use the classical and quantum computing. So when you look at the classical and computing, so it circulates with the qubits, which can present 0 and 1 at the same time. Classical computing 0 and 1, 0 or 1 only takes. The power increases exponentially in a proportion in the number of the qubits, but the power increases in a 1:1 ratio or relationships in the number of the transistors. Quantum computers has high error rates and need to be kept ultra cold. Classical computers has the low error rates and can operate in the room temperature. Our systems can work in our home itself, but quantum computers will not work in the room temperature. So it requires a ultra cold or ultra temperature. So then it is well suited for the tasks like optimization problems, data analysis, molecular simulations, molecular dynamics, where you are intended to analyze molecular trajectories of a system. Traditional systems are classical computers most everyday processings like your PPT preparation, seeing the movies and preparing something and content development and writing his programs and etc. So it is best handled by the classical computers. So error correction is mature and simple in the classical, but quantum computing is a complex and still under research because it need to be addressed. It is not fully available form. It is still research is going on to sort out some of the issues. So the classical computers uses the office purposes, office applications and games. But these quantum computations are specialized in a particular sectors that are called factoring, quantum simulations and optimizations. So hardware, whichever we used to use in the classical systems, that are the silicon chips and transistors. Here the quantum computing used semiconductors, circuits or trapped ions or photons. Trapped ions and photons will be used in the quantum computers. So here is the various algorithms will be used, that are the Shor's algorithm, Grover's algorithms, etc. are there in the quantum computing. So that we will discuss in the upcoming slides. So this, when it comes to the availability, so classical computers anyone can buy and use it. That is a affordable prices are, but quantum computing is not affordable. It's a costly and expensive, and it is a limited and mostly exponential cloud-based systems are there. Then temperature requirement, our systems will work in a room temperature, but it often requires, quantum computers requires the cryogenic environments where you have either 0 degree centigrade or -1, -2, -3, -8 temperature will be taken. So that much cold temperature it requires for the quantum computing facility. So this is about the traditional programming and quantum programming when you are writing a programming. So here the programming can be written in a C program, Java program, Python programming and JSP program, HTML, etc. you have. But quantum computing programming is somewhat different. That is QI-SKIT. We have a scikit-learn is there, no? Similarly here, QI-SKIT, it is a Python-based libraries, and CIRG and QAsh, Penny Lane, bracket, etc. are programming languages that are developed for a quantum computing purposes. So execution model, here the sequential and parallel will be there in our traditional system, but quantum computing, it is a circuit execution on quantum processors. So logical operations, it uses your Boolean operators and or not, but here it uses the gates. The gates are called Adam mode, C naught, Pauli X, etc. These are the quantum gates. Control flow. The control flows are if else, loops, functions, etc. will be used. In the quantum programming, it uses the limited classical controls that uses the quantum circuits and measurements. Wherever you have a RAM, so RAM will be used for a memory access in the persistent storage in the classical systems. When it comes to quantum programming, it uses the registers. The registers are the temporary memory in the quantum states. There is no direct memory access in the quantum registers. So determination is a deterministic state. From the input to the output will come in the traditional systems. When it comes to the quantum programming, it is a probabilistic measurements, it is measurements can yield different outcomes. So error handling is try and catch, or we can put some of the debugger conditions. So then we can able to breaks we can use and we can debug the program. But error correction is hardware level in the quantum computers, and it's a complex. The computational style is the step-by-step manner or sequential manner in a classical programming, and quantum programming is a error correction is parallel computations via superposition or entanglements. So whenever you wanted to write a program in a traditional programming, you used to use traditional consoles or IDEs or Visual Studios, Eclipse, and some of the PyCharms and other tools, or Jupyter, Anaconda, or Colabs, etc. we used to use. When it comes to the quantum programming, we used to use the quantum platforms such as the IBM Quantum Lab, Microsoft Quantum Development Kit. So these are the tools, development tools that are available, so which we used to use for a small type of the computations. Applications, we used to develop the web applications for the data sets, databases, mobile applications, games, etc. But when it comes to the quantum programming, so we have a quantum simulation and cryptography, optimizations, and machine learning tools, etc. So what is the concept of a power growth in a quantum computing? The quantum computing, the power growth. So whatever you have a classical computing, so it is a linear growth. The linear growth is nothing but you have a 1 and 2 or 3. So you are adding the sequentially 1 by 1. That is, you can add more bits. The computing power increases step-by-step manner. That is called linearly. For example, you have a 2 bits. It is possible to make the 4 bits. You have a 3 bits. It has the 2 to the power of 3. Let us assume it is a 8 possibilities. Similarly, 4 bits, it is a 16 possibilities, etc. The growth is steady state. The growth is predictable in a classical computers. When it comes to the quantum computing, the growth is exponential. When you are adding to the qubits, the computing power grows exponentially. So how it will goes? For example, 2 qubits, 4 states, 3 qubits, 8 states, 10 qubits, 1024 states. Okay. So like that, the exponential rate will be there in a quantum computer. So these are only because of the qubits. This is the capacity of the quantum computing. It becomes the enormous levels compared to the classical bits. So in short, the classical computing grows like a climbing one step at a time. But whereas quantum computing grows like a jumping multiple steps at a time. So that is a power of the quantum computer. So when I talk about the architecture or hardware, this hardware, the superconducting qubits, today IBM and Google, and trapped ions will be used by the LAN cube, photoionic systems, and various challenges that are there in a error correction and stability levels in the architecture. So this is the quantum architecture. And whenever you wanted to use the algorithms, what type of the algorithms will be there in a quantum? So we have the Shor's algorithm. We have the Shor's algorithm. The Shor's algorithm was developed by the Peter Shor in the 1994. What this algorithm says, it is a first try to find out the primary factors or prime factors in a large interior poles. So whenever you have a large interior poles, that is called a polynomial. So it is having a potentiality to identify and ability to break the encryption levels. Then the foundation of the modern cryptography was major catalyst for the investment of the quantum computing. So that is the Shor's algorithm. Then another one is called the quantum Fourier transformations. So this is a QFT we used to say. So whenever you have essential subroutines, the essential subroutines for the many computational algorithms, that includes the Shor's, the QFT can analyze the periodic patterns within a quantum state. The quantum state exponentially faster than its a classical counterpart. So that is the QFT. And we have a Grover's algorithm. What the Grover's algorithm will do, first is to try to find out or search where you have unstructured data. This is where you have unstructured data of n times. Then Grover's algorithms can find a target item in approximately square root of n. Square root of n steps, offering a quadratic speed of over the classical search time that is called ON. Then what are the variational quantum eigenslowers? The variations of the quantum eigenshowers. That is the eigenshowers is, it is a hybrid algorithm that finds the ground state every molecule or ground state or kinetic energy of every molecule. That is called the starting energy levels or primary levels of every molecule. The quantum processors prepares and measures a trial quantum state while a classical optimizer minimizes the energy. So quantum approximate optimization algorithms that are designed for a combinatorial optimization, that is a combining of a 2-3 algorithms. So the combinatorial optimization problems that comes up with the hybrid algorithms, because you are integrating, you are merging the 2-3 algorithms, that is a hybrid algorithms. So this hybrid algorithms uses a classical optimizer to find the best settings for a quantum circuit. It has applications in logistics, finance, and scheduling. So global leaders in the quantum computing is IBM Quantum, Google, Sigma More. So IBM has the quantum and Google's Dynamo and Microsoft Azure Quantum, and some of the research organizations in India, IISc, IITs, ISROs are initiated for establishing the quantum computing facilities. So it is under the trial and error stage. So these are some of the software consultants that are there in the quantum sector, and some of the quantum computers, as I told you, the IBM, Google,
Sir, your voice is not audible, sir. I think so. You are on mute, sir.
So we have a various applications in the quantum computing. So the first come with the qubits and quantum mechanics and analytics, blockchain technology, innovations and research labs, and cryptography and artificial intelligence and disruption strategies. So quantum computing dealing with all types of the applications. We'll see the one by one. So this is the landscape of the quantum computing. So you look at here, you have the development stage, you have a implementation stage, and you have a semi and superconducting qubit stage. So look at here, the optimization conditions. You can optimize a number of the problems, or your optimization will be a quantum annealing methods that is integrating with the different ions and tapped the different ion CNS levels. And whatever the simulations you wanted to do, the simulations that are integrated with message passing interfaces, these message passing interfaces will be interacted with the machine learning protocols and machine learning methods. So then you have simulations. That simulations also deals with the biological phenomena problems and material science problems and chemical science problems. And you have a trajectory file systems and ISRO and other sectors which you use it to use. And that are the computations and simulations generated. That enormous data will be generated by these trajectory files. When it performing the simulation, the storage issue and performance issues will come. The traditional computers are not in a position to support in the larger simulations or larger computations, but quantum has the capacity to do multiple processors or multiple computations at a time. So that is a superconducting and linking the facility with the superconducting the computers in the these qubits. And look at here, we have some of the main things. When talk about the application point of view in the bioinformatics, the quantum bioinformatics, that is in the short form, we can say the QB. When it comes to the bioinformatics, it's a nature of the combinatorial operations. And whatever the combinations, you have a sequence. The sequence may be a DNA and RNA. That sequences you need to design, you need to model the structure, or you need to build the structure by using the various computational methods, computational tools, and that you have to give up some of the quantum concept today. So we have a different platforms, either it is a classical or quantum. So then, whatever the platform you want to adopt, you can adopt, whether classical computer or quantum computer. And the type of the data, if you are adopted the quantum computing, that is a QB, quantum bioinformatics, it's a quantum biological data you have to use, right? The data you need to see, we used to do the autoencoders and epochs in the machine learning. Similarly, when you are using the quantum computing in the bioinformatics, you have to do it in the quantum biological data. The quantum concept in the bioinformatics, it's called as the QCT. It's a nature of the computations is modeling and building of the computational models, tools for optimization of a concepts that use it to use the classical biological data. The classical and traditional biological data use it to use. Then we have a quantum computing in a bioinformatics. This quantum computing in a bioinformatics is called as a QCG. Here, the type of the platform which we used, the quantum computer, and type of the data being used in the classical biological data. Quantum computer in bioinformatics is a QCR. They use it to use various applications of the machine learning or classical bioinformatic tools or QCT bioinformatics tools in the analysis. So that is the type of the platform is a quantum computer. The type of the data is a classical or quantum biological data being used. So these are the only few applications and few processors that are there in the bioinformatics or diverse applications and methodologies within the quantum field. So when you talk about the quantum biology or quantum bioinformatics, it starts with the sequencing. Then whenever you have a sequence, you need to develop the structure. Whenever you have a structures, you need to check the structural similarities. The structural similarities will come up with the superposition. That is a quantum superposition in a biology. So when you have two structures, you need to superpose how they are binding, how they closely associated, you need to check. So that is a superposition. The quantum computing also works with the superposition. Then we have an entanglement in the biology because one organism is associated with another organism in terms of evolutionary context. Within the organism, you have a genes and proteins. The genes and proteins are interacting with the one gene with another gene will interact with the another gene. Similarly, proteins also will interact with the one with the many. Our biological phenomenon is a complex networks. It's a 10 to the power of 18 connections and 24 networks are there. So that means it has an entanglement. So the quantum entanglement is there in the bioinformatics, which we used to use. Then we need to interference. Interference will be there. So interference will be there in the communications and process and relationships between the one with the others. And then we have a coherence. Evolutionarily, coherence differences will be there. So tunneling patterns will be there. And photonics, using the solar system and using the evolutionary strategies, the photonics will be. And today we have various types of the sensors. The artificial intelligence are neural networks for the inspired from the biological neuron. Biological neuron, how the biological neuron works, the neural networks is developed. The genetic algorithms, how the genetics will work, like linkage and crossing over and mutation and population. Then the genetic algorithms. Similarly, how we have a sensory organs in the body, like tongue, like ear, like eyes, like your physical touch, like your nose. So, sensing biology, the quantum sensing biology. Then complexity, because human body is a complex system. Then you need to understand various physiological conditions, various anatomical functions, and various types of the pathways that are associated with your body. That is complexity in the biology. Then quantum information science in the bioinformatics and biology. So the information science that pertains with the chemicals and biological and bioinformatics, biochemistry, microbiology, genetics, etc., sectors are there. So they all are the associations. The quantum consciousness in the biology. Always the biologist and bioinformatician in the consciousness, they used to do the experiments and produce the results. So like this, the applications that are organized in the quantum mechanics and that can produce the kind of biological consequences in the quantum biology and quantum bioinformatics. When it comes to the biological data, so the classical biological data set that includes the variety of types of the DNA sequence and protein sequence that has the information that including the genomic data, it's a genes, proteomic data, it's a proteins, and metabolomic data, that is a I'm getting the hungry, मेरे को बहुत लग रहा है. It's a metabolomic system. I'm getting the urine, I'm getting the feeling of a stomachache or a headache. It's a metabolomic information, metabolomic signals, metabolomic communications, right? So that is a classical system. But where you have a classical biological data that need to be converted into a quantum biological data, then quantum biological data set is a collection of the information that is obtained by the quantum physics tools on biological samples. So whenever you have a quantum biology, the quantum biology is primarily revolves around the extraction of a quantum data from the biological sources that utilizes the laboratory tools rooted in a quantum mechanics and quantum chemistry. The primary objective of the quantum biology is to unravel the fundamental principles of a quantum mechanics within our human body, within our animal body, within our parasite body, within our microorganisms body. That is, various biological systems. Within a biological systems, we are trying to find out the fundamental principles. They unravel the concepts. So when you have a quantum bioinformatics, the quantum bioinformatics involves in the development of a tools, development of a models, development of a algorithms, and designing of a computational tools and optimization techniques where we used to use in the molecular modeling and molecular dynamics and molecular simulations by optimization methods by using the force fields. So these techniques leverage the quantum principles for the various biological purposes. So these applications encompass the data mining in the quantum biological data, utilizing the quantum computer platforms in bioinformatics, and employing the quantum computing as a tool for analyzing the biological data. So this is the overview of a few concepts in the realm of the biological data in terms of a quantum biology, quantum bioinformatics. So you have the drug design and drug discovery. So earlier, everybody used to develop the drugs in the chemistry laboratories, but now in the computationally, we are designing the drugs. That is the computer-assisted drug discovery, computer-assisted drug design. So first we try to identify a disease and make a hypothesis. Then we try to find out the disease based on the signs and symptoms of the patient. Then we look at the similar kind of the signs and symptoms in the various patients, someone from the Yeluru, someone from the Gunturu, someone from the Vijayawada, someone from the Vishakhapatnam, someone from the Kakinada, etc. That is called pharmacological properties or pharmacogenetic properties. Then we wanted to generate a drug molecule for that. Then first we have to find out what type of the drug can work to them. So then we need to study the pharmacogenomic levels. There is single nucleotide polymorphisms. Then we need to find out the lead molecule out of the lakhs of the molecules. We need to find out the only one or two molecules. That is called lead generation. To lead generation, we need to optimize the coordination properties. So you might have known everybody has the benzene ring, C6H6. If C6H6, you may add the OH, phenol. If you add the NO2, it's a nitrobenzene, etc., etc. If you add, so that is the different properties are added that are called coordinates. We need to optimize the side chains. We need to optimize the coordinates. That means that you are minimizing the structure. When you minimize a particular selection or site selection optimization, it brings the molecules into a stable form. Then you try to find out whether this molecule will dissolve in your body and it will enter into the metabolism, it will be excreted. That is called absorption, distribution, metabolism, excretion, and every molecule has a toxicity. So then causality analysis for the side effects. Then you need to fix up the dose. So as we know, paracetamol tablet available in a, if it is a 500 mg and 650 mg. But whereas you wanted to give the same paracetamol for your kids, 100 mg will be there, 250 mg will be there because you are giving to the kids. So, but the same compound will be there in a syrup form as well as the tablet. But it is also available in a injection form. So, that is a dose fixation, dose optimization processes will be there. Then we need to check the property of the solubility. So the drug has to be dissolved. So that also we will see in the taking patterns. So these patterns, we need to, whatever these semantic patterns or whatever the traditional practices are there, this we need to convert into a computer approaches. This will be checked in the computationally by using the Beeman's algorithm and Matarki algorithm and feed-forward algorithms and Viterbi algorithms. So, by developing the computational algorithms, that computational algorithms will mimic the nature. Then we need to produce how the drug will work in market, what are the competitors, then optimization of the catalytic processes, then product formulations, quality monitoring. We need to check the quality of the product and predictive maintenances. Then we need to see the logistic supply of the material and dynamic inventory and warehouse practices and procurement and optimization of a raw material. Then you can enter into the market. So this whole process is normally takes 12 to 15 years of a time for bringing one new drug into a market. So the effects of the quantum computing on computer-assisted drug design, whatever the hypothesis you have, the hypothesis can optimize active pharmaceutical agents, that is, the pharmaceutical ingredients. So one of the longer time scale, the quantum computing is expected to change how the hypotheses are found by using the machine learning tools to predict the structural properties. And this potentially predict the three-dimensional structure target proteins. When the quantum computing itself synthesizes the new molecules, test the medical properties or medicinal properties of a compound, and it will assess the different its identity levels of the lead molecules 5 to 20 times. So the evaluation, the quantum computing can potentially reduce the number of the development cycles and increases the quality of the optimized lead compounds. This is the effects of the quantum computing in the computer-assisted drug design. So some of the key aspects that are used to use in the pharmaceutical industry, the maturity, whatever the incubation, whatever the molecules which you have, so that will come into the fundamental research of any product you wanted to make it a commercialization, then R&D studies should be there. Some of the existed drugs will be competitor, then you need to know how the disruptive changes. Then in emergence of the latest technologies, you need to adopt it for the newly generated algorithms. Then commercialization, wherever the quantum computing can be bring early value. So then the commercial R&D can be, business development will be used, and disruptive changes and incremental changes will be adopted. So then the value-based pricing also will be predicted. So this is the target identification and validation methods will be there in drug design and drug discovery, various protocols in various pipelines which we use it to use in identification of a drugs. And so whenever you have all these scenarios, so first you undergo the literature review, literature studies, and find out the root cause for the disease and check the properties that are associated with your disease. Then carry out your traditional systems, and we perform the molecular docking and dynamic studies and simulations. But the traditionally that are not sufficient to do all these type of the things, right? So then we have a target identification and validation. So this target identification and validation can be performed the various things. And questions for the reflection and strategic stance for the quantum computing. So will quantum computing demonstrate the promise to the disrupt many areas of the recognizable the competitive landscapes, and that can dedicated to the requisite and investigate the quantum computing opportunities. I can scale up the capabilities, and you can follow the evaluations and prediction measurements and etc. So then you can protocol will be used. Then the hypothesis in the quantum computing advantages in the molecular modeling. So molecular modeling uses the variety of the computerized techniques to predict the chemical property, biological property, or physical property of a particular molecule by experimental data. Whatever the data you have in experimental, then that you are transforming into a computational models by using the CAD. So these computational chemistry, drug design, and computational biology and material sciences will be used. Then database searching, quantum computers are used to store and search through the massive amounts of the data in a much quicker time than traditional computers. So data security in the future, the quantum computing may play the quantum computing may play an important role to store and search throughout the massive amounts of the data in much quicker time than the traditional computers. So data security in the future, the quantum computing may play a significant role in a network in cyber security. So weather forecast. So weather forecast we are seeing sometimes it is a misinterpreted data. So they said the last 4 days continuously heavy to moderate to heavy rainfall will be there. But governments gave the holidays to all the schools and offices, but there is no rainfall. So sometimes the data interpretation will be there because forecasting may not be happen correctly. Then we have a data security and weather forecast. Quantum computing will assist in the improving the local and global weather forecasting for more advanced and precise warnings of the extreme weather occurrences. The potential is saving the lives and lowering the annual property damage. So then you look at the various aspects of the quantum computing, drug discovery and molecular simulations. There are the challenges. It stimulates the complex molecules, for example, the gene and proteins. Then, extremely computationally intensive for your classical computers. Quantum advantages, the quantum computers can stimulate quantum interactions naturally, that enabling the faster drug discovery and better understanding of diseases and customized medicine. So, for example, IBM and Google and Qubit Pharmaceuticals are working on the quantum simulations for the molecules can work like a penicillin, can work like a caffeine. Then cryptography and cybersecurity challenges. So cryptographic systems like RSA, it relies on the factoring of the large numbers, such as hard for the classical computers. Quantum threat, algorithms like Shor's algorithm can break the RSA encryption efficiently. Then quantum safe future. While quantum poses a threat to current systems, it also enables the quantum encryptions like quantum distributions that is theoretically unhackable. So the artificial intelligence and machine learning current challenge, the training deep neural network is very compute intensive. The quantum advantages like potential to the accurate training, the quantum enhanced pattern recognitions like solving unsupervised learning problems more efficiently. Real work, the Google's quantum team is exploring the quantum neural networks. And the quantum computing being used in the traffic identification and identifying the possible routes or exploring the possible routes. So we are also using the optimization of problems that are industrial affected logistics, finance, and manufacturing and supply chains in the various sectors that are there for a optimization of the procedures. So then these use cases, the finding the best route to travel reach the particular location, to avoid the traffics, to avoid the where you have a troubles and speed breakers and various traffic signals and a heavy public interventions are there. So we are trying to identify the best route and the combination, and we wanted to schedule our possible things, scheduling of the million possibility. Quantum advantages, the quantum computers can explore many combinations at once using the quantum parallelism, that are airlines are being optimized the flight routes, because we at a time many flights will be going in a same manner. So try to find out the optimization levels. So longitudes and latitudes will be differs, and the distances will be given different. International flights will go by high altitude levels, and domestic will go the low altitude levels. And parallelly will go a number of the flights in a same path to reach the particular distance. So we need to optimize. Then shipping companies optimizing the delivery of the logistics to take many days, and financial portfolios for being the optimized of the risk rewards and other things. Future outlooks, the hybrid computing. So whatever the hybrid computers which we are using, so the classical computing and quantum computing will be hybridized. That is called hybrid computing. The quantum cloud services, the quantum is coming up with the cloud architecture and cloud services. The expected breakthroughs in the next decades, which we are assuming, and challenges, any technology that is arises, challenges will be there. So that is called the challenges with the quantum computing, that is the deterrence. So these quantum computers are extremely sensitive to environmental noise. which causes the qubits to lose their quantum states. So that is the reason we used to say the temperature is the 0 or -1, -2, -5. This introduced the errors into your computations, requiring the sophisticated error correction techniques to build the practical and fault-tolerant systems. Scalability. The current systems have a limited number of the qubits. The scaling to the millions or billions of the physical qubits needed for a complex problems is a significant hardware and control challenge involving the managing the interactions between the many qubits or developing the scalable control electronics. So high cost and accessibility. The specialized hardware and cooling systems are required for a quantum computers, but these are more expensive and their accessibility is limited. So the talent shortage, because we don't have the sophisticated talent or the whatever we are expecting the students or professionals, it's a very few are there. So that is called the shortage of the talented or proficient persons in the quantum. So there is a significant shortage of the experts with the necessary skills in quantum physics, quantum engineering, quantum statistics needed to advance and utilize the technology. So ecosystem is developed. The comprehensive multi-stakeholder network is needed to translate research into a real-world applications to define the clear. So in conclusion, quantum computing is a paradigm shift today. It holds the transformative potential for the various industries and scientific fields, but it is still in the early stages of the research. But quantum computing has the potentiality to solve the problems that are impossible for the classical computers, requiring the significant technological advancements and investment and interdisciplinary collaboration to overcome the challenges like qubit, scalability, error correction, and scaling. So with this, I will stop it here. If you have any questions, feel free to ask me. Any questions, please?
Sir, there are a few questions in the chat box, sir.
What are that, sir? I didn't see. Okay.
Last algorithm of the quantum computing, sir. They were asking regarding that, I think.
Just a minute. Let us see.
And the other question is future of quantum and quantum algorithms.
See, the quantum algorithms are being developing now. So quantum algorithms are very fast and robust algorithms. They performs the computations are very fast, and the infrastructure is the issue. Infrastructure is a problem. That is the biggest challenge now. So somehow they are trying to optimize that. Once it is optimized, it's made it available for everyone, maybe upcoming 10 years. And any other questions? What we can afford have a quantum? No, individuals as of now we cannot afford the quantum computers. It is a difficult because you require a architecture and infrastructure and qubits. Qubits will not work in a normal systems like nature. It requires a lesser temperature and it requires a special hardware. The hardware itself will expensive. So then there's another question. So what is the difference between the quantum ML and quantum federated learning? So whatever the traditional machine learning which you are using, so whatever the ChatGPT, whatever the OpenAI you are using, it is tenfold faster than the traditional ML methods. That is the quantum ML methods. Anything else is there? Okay. So I think I addressed, sir. Still, if there are any, then I will answer. So which type of the projects are making the quantum computing, including the machine learning, also with the cyber? So as of now, many of them are trying to work with the cyber security, and but this quantum computing will has the noise. So will have the noise. This noise decoding, like denoising algorithms, they are developing now. So the denoise algorithms, if works, so it gives a revolutionary in the quantum computing approaches. I hope I answered. So there are no questions in the chat box, sir, no?
Hello, sir.
Yes, sir.
Sir, this is Dr. KVS Rao from NRI Institute of Technology, sir.
Settle, Mr.
So, thank you, sir, for giving a wonderful lecture on quantum computing. Even the beginner understands the way you explained the quantum computing. So, it was a smooth sailing, sir. But I have some questions, sir. Like
Yes.
yeah like how do we use quantum computational process to our day-to-day lives when the quantum costs are very high? That is one question. For example, IBM is offering quantum computational services. So it is charging $48 per minute. So if we have to run the program for 10 minutes, 448, $480 we have to pay. So that comes about 44,000 rupees for 10 minutes. So how companies overcome from this high cost, sir?
Yeah, I understood your situation, sir. As of now, we have only that opportunity. We are trying to develop. This is in the beginning stage. Many companies are starting working on this to denoise it and decode how best we can do. Because everything is coming up with the architecture level, hardware level is the issue. So the qubit, anything is happen, errors comes, you have to check it in the qubit levels. The qubit will goes to the architecture level only. So you have to look at the hardware levels. So maintaining the hardware is an issue in the quantum computing. So that is the reason many companies are not not investing much. Only few companies are invested. If development of a algorithm, development of a software, a number of the companies will do. Yes, sir.
Yes, sir. So I have a small news, sir, at this forum. Government of AP is starting Amravati Quantum Valley in Amravati. So in collaboration with IBM and TCS and L&T. So in another 4 to 5 months, this is going to come up. IBM is going to establish 156 qubits machine, quantum machine, wherein the government of AP will maintain the entire services like cryogenics minus 272 degrees maintaining,
Yes.
and the power bills are going to be paid by the government of AP. In turn, IBM is giving the quantum time to all the to the government. In turn, government is transferring the quantum time to most of the colleges. This is what is the government has government is planning, sir.
That is well and good decision from the government, sir.
Yeah, it will be a boon for most of the engineering colleges, faculty members, students, and a great ecosystem will be developed centering at Amravati.
Good decision from the government, sir.
Is a small addition to your explanation, sir, for the information to the participants.
Okay, good.
Prashant, you can conclude.
Thank you, sir, for enlightening us with your words of wisdom. Your session has helped us to gain knowledge on the introduction of quantum computing, applications of quantum computing, which includes drug discovery, cryptography, and finance. And the global leaders of quantum computing. Quantum computing includes IBM, Google, and Microsoft, etc. And the history, the significant role of qubit, properties and principles of qubits, and the power of quantum algorithms, integration with other technologies, landscape of quantum computing, and etc. Thank you so much, sir, and we wish to collaborate with you again and again, sir. Thank you.
Thank you, one and all, for the patient listening. So may I leave, sir?
Yes, sir, you can, sir.
Okay, thank you, sir.
Thank you very much, sir.
Yeah.
Now I'd like to call upon Roja madam to introduce the session speaker. Over to you, ma'am.
Good evening, one and all. Myself, Roja Priscilla, faculty member working for Department of Computer Science, PB Siddhartha College of Arts and Science. It is my privilege to introduce Dr. Venkata Sivasambarao Kambampati, a distinguished academician, researcher, and administrator in the field of computer science and engineering. Dr. Samba Sivarao Sir currently serves as the Dean of NRI Institute of Technology, Krishna, Andhra Pradesh, where he has been leading academic and research initiatives since 2014. He holds a PhD in computer science from IIT Delhi, an ME from BITS Pilani, and BE from the University of Mysore. His expertise spans cybersecurity, artificial intelligence, software engineering, and computer science theory. And he has made remarkable contributions through research, publications, and innovations. Over the course of his career, Dr. Sambasivarao sir has authored several books and numerous research papers on cutting-edge topics, including AI, machine learning, data science, and cybersecurity. He is also credited with multiple patents in areas such as AI-driven healthcare technologies, culturally aware sentiment analysis, and soft fabric exoskeletons for rehabilitation. Dr. Sambasivarao sir has been instrumental in organizing international and national conferences, faculty development programs, government-funded research projects, supporting advancements in AI, deep learning, and higher education reforms under NEP 2020. His exemplary work has been recognized through several prestigious honors, including the Best Research Award 2022, Best Teacher Award 2020, and the Eminent Educationist Award 2013. With over 3 decades of experience, Dr. Rao stands as a beacon of excellence in education and research, inspiring students, faculty, and fellow researchers alike. Please join me in welcoming Dr. Venkata Sambasivarao, sir. We welcome you, sir. I request you to take over the session.
Thank you, madam. So thank you, madam.
Thank you, sir.
Yeah. Yeah. Can you see my screen, madam?
Sir, it's visible, sir.
Okay. So thank you very much for introducing me to the participants. Can I put off my camera because I want to save my bandwidth?
No issues, sir. You can say. Thank you.
So thank you once again for introducing me to the participants. I am Dr. K.V. Sambaseva, working as Dean for Computer Science and Engineering Department at NRI Institute of Technology, Agirpalli. So my topic in this faculty development program is on advancements in cloud computing. So I sincerely thank the organizers, especially Dr. T.S. Ravikiran and his team members for identifying me as one of the resource persons in the faculty development program, which is sponsored by AICT Atal Academy. So the table of contents or agenda for this meeting today are the following: introduction to cloud computing. What is the cloud computing? Right from basic introduction of cloud computing to the advancements we sail through. So cloud architectures, various models of cloud such as deployment models, service models, then the benefits offered by the cloud computing, applications and trends, and advanced architectures such as microservices, containers, serverless computing, cloud security, data management, AI ML in the cloud, and other emerging technologies such as edge computing, fog computing, quantum computing, green cloud, so which are emerging into the cloud space. And a few case studies if possible, and the best practices and future outlook I'm going to discuss. So first of all, let me introduce what is a cloud. So as this forum is comprising of number of faculty members and PG scholars from various institutions, so maybe having the introductory knowledge about cloud computing, or they may also be having the advanced knowledge about cloud computing. However, I would like to give the introduction about cloud computing and gradually go ahead with the advancements. So first of all, what is a cloud computing? Cloud computing is the delivery of computing services over the internet, which we call it as the cloud. Instead of having the local server or personal computers, uh, it is nothing but renting resources on demand from a third party instead of owning every hardware. So, and cloud services include the servers, storage devices, databases, networking, software, analytics over the internet. So these cloud services are readily available in the cloud or the cloud infrastructure, and the users can approach the cloud and they can avail whatever the service they want. So to relate the cloud computing with a kitchen. So these days many people are discussing about cloud kitchen. So the we will have some analogy with respect to kitchen and cloud computing. So kitchen, say for example, if a person has established a cloud kitchen, so kitchen is open and it provides services, various kinds of services. So like the space, utilities, equipment to run multiple cuisines or multiple dishes in the kitchen. Say for example, that becomes a cloud infrastructure. Cloud station, cooking station, so where there will be a number of stoves, ovens, and utensils. So they work here as the cloud servers. So servers basically they provide the executions when the customer arrives at the server with some kind of code or modules. So they are executed with the help of server. Similarly, in the cloud kitchen, the stoves, ovens, utensils are readily available. So when the customer approaches the cloud kitchen with the necessary ingredients, probably they can cook there. So second facility at the cloud kitchen is raw ingredients storage. So there is a storage space such as fridge and pantry places available in the cloud kitchen. Similarly, in the cloud, we have the storage facility. So where the users can store their files, users can store their files, the applications, etc. So third one, the receipts and menus. Recipes and menus in the cloud kitchen. So there will be number of recipes and the menus are available. How to cook a particular recipe. So the entire details are mentioned in the cloud, mentioned in the cloud kitchen. Whereas in the cloud infrastructure, it relates to databases. So the databases are available. So or the users can store databases where they can access live information, or they can do some kind of analytics. So when comes to the delivery apps or networking, so in the cloud it is a networking, whereas in the cloud kitchen it is delivery apps like Zomato people. So they are connecting various customers, so of the cooked food item which is delivered, like Uber Eats, etc. The customers, so the customers get the delivery of the required food. So whereas in the case of the cloud computing, networking is possible. So the person who is owning the cloud space can offer services to the customer. And coming to the scalability, uh, so when more orders are there, we have to increase number of chefs, we have to increase the space, we have to increase number of stoves, fridges, etc., the infrastructure. So this is also called as elastic cloud. So cost efficiency is that you don't have to have all these cloud infrastructure or cloud kitchen. So wherein the customer is utilizing the services or the food, and they are paying only for the delivery. So they are paying only for as they use. So the impact is that there is explosion of cloud-based applications in IT, especially these days. Most of the companies, most of the individuals, their data is stored in the cloud, in the one or the other clouds, and the companies are utilizing the cloud storages. They are deploying databases in the cloud. They are utilizing servers because servers have higher capacity to run bigger programs, so which they don't have to maintain huge infrastructure. And most importantly, the cloud services are available on demand and pay as you go model. So it eliminates need for heavy on-premise infrastructure. So one need not to have a huge mainframe computer or huge infrastructure on IT for their regular business applications. So it saves storage space, reduce costs, and saves time. So coming to the evolution of cloud computing, right from 1950 to as of today. So this is a ladder which is showing the developments relating to the cloud computing. So in the initial days, so there were the computers, so which are having limited computational facilities, uh, and when a bigger program has to run on a single machine which is not capable of holding which is not capable of executing the entire code. So in such a case, the program is arranged or is distributed to different computers, so where each computer take a specific task and they execute, and the final results are arrived at a single station. So the distributed computing started in 1950. So later on, the mainframe computing, that is a centralized computing, this concept was evolved in 1960. So where the organizations build huge mega infrastructure with respect to the computing, such as mainframes. So these mainframes are capable of handling bigger programs, and they are working on time sharing basis. Probably if different users want to utilize the mainframe computing, so they can request for some time to use the time of the mainframe computing. So later on, the cluster computing, where different computers work as a single station and the bigger programs are executed. Grid computing is a similar concept to cluster computing. where number of systems do process like a single node, and virtualization which happened in the 1980, where one single machine or a mainframe computer, so some part of the hardware, some part of the software, some part of the operating system, they are identified as virtual machine, and these virtual machines are given on time sharing basis. So this concept led to the development of cloud computing, uh, and web to service orientation, utility computing, cloud computing. So right now, in the year 2002 to 2007, the cloud computing has evolved and has reached to the maturity level. So 2010, there is advancements in cloud computing such as edge computing or fog computing. So edge computing is that most of the devices, they process locally and they submit data to the cloud. So such as the IoT devices. Say for example, we want to note down the air quality index of Vijayawada or different cities. So the IoT devices, Andhra Pradesh Pollution Control Board has deployed around 170 stations across the state. So each station at the ground, they identify, they sense the various parameters in the air and air quality. So they are processed locally, and air quality index is derived, and that simple data is submitted to the cloud. So as an user, the user can see the air quality index of Vijayawada or other cities or other parts of the country. So where single cloud gives the entire information of various cities, so having a different air quality indexes. So that is possible with edge computing. So fog computing is the middle layer between edge computing and cloud computing, and AI driven cloud. So these days, the AI based cloud operations are happening. So since AI is nothing but artificial intelligence, where uh, machines are made as intelligent machines. So they think, understand, they plan, they work like the human beings. They imitate most of the activities of human being. So intelligent activities or automated activities are handled in the cloud, so without specifying clearly with the instructions to the cloud. Say for example, utilizing the server, or utilizing or storing data in the databases, or networking various people like the service provider and the customer, etc. So once again, coming to the evolution of cloud computing, 1960s, mainframes and time sharing. So this system was evolved, and multiple users accessed single mainframe. So the concept is shared computing began during 1960s. During 1990 and 2000, virtualization or virtualization machineWare, so VMware, so has come into the existence. Efficient use of hardware through virtual machines. So a mainframe computer can partly give the CPU time, partly give operating system, partly give the hardware. So that this becomes a virtual machine, and the virtual machines are configured. So different number of virtual machines are configured as per the needs of the customers, and they can be utilized by the customers. So in 2006, the first cloud was launched by Amazon Web Services. So it is the public cloud service which has disrupted entire IT infrastructure. Disruption means stopping of the existing practices, such as the companies or individuals procuring higher capacities of infrastructure, such as computers and software, etc. So and 2000, especially software, coming to software. So if I want to have a wide range of software to use, I cannot afford to purchase all kinds of software, and hence these days the cloud is providing various kinds of services, and I go to the cloud, use the software as a service, and I I work out with my application. So 2010, containerization with Docker and serverless, these concepts I'm going to explain. So containerization is nothing but a module, so which is linked with the dependencies. Say for example, we have a big program. So the program should be supported by some data sets. So both the things are put together, which is called as containerization. Or the program requires the math library or the graphic things like that, and they are put together and they are managed as a container. So it is a simplified process for the customer, for the developer, whereas he can develop the applications very fastly. He can deploy the applications very fastly, and microservices uh, and pay per execution, the cloud too has evolved. So during 2020, AI driven edge computing or edge integrated cloud computing. So these days, the cloud is becoming very intelligent, and automation concepts are introduced with respect to operations of cloud computing. So coming to the features of cloud computing, it is elastic because, uh, so as I said, in the cloud kitchen, if the number of orders are more, so we engage more number of chefs, we engage more space, we use more ingredients, and we deliver the services. So similarly, the cloud can be utilized as per the requirements of the customer. So sometimes the customer needs heavy usage of the cloud, and in such a case it is elastic. Or sometimes later, so he is not having much of the application, so he is using the paper usage application. So cloud computing is flexible in nature, whereas users can scale up or scale down the resources as needed. So pay per usage is metered, and users are charged according to the usage. Operations, the services are completely handled by the provider. So in the cloud infrastructure, most of the operations are handled by the provider. So it reduces the capital cost of an individual or an enterprise. No need to invest money on purchasing and maintaining hardware, software, firmware, etc., and no training is required for IT staff. So remote accessibility, users can access applications remotely across the globe. So wherever they are, they can access to the databases, access to the services, access to the data which is stored in the cloud anywhere across the time, anytime. So 24 by 7 they can access. So better use of IT staff. IT staff need not concentrate on establishing infrastructure, maintaining infrastructure. So instead, they can concentrate on developing more applications for their customers. So coming to the cloud computing architecture, so we have a two-layered architecture. One is the front end, second one is back end. So front end is mostly related to the customer or client. So where the client is having various kinds of devices and the computational facilities, such as he is having a desktop computer, he is having the laptop computer, handheld devices, he is having browsers, some softwares, some applications. So only thing he has to approach the cloud through the internet. He has to have the internet. So the phase is back end. So that is this entire infrastructure is maintained by the cloud service provider. So it is layered into five layers. So first one is application layer. So in the application layer, users interact with these without worrying about infrastructure. Say for example, the cloud service provider will provide use of the Microsoft Office or Salesforce or some other application which are readily deployed. You just go there and work in the application layer. So they provide end user applications directly over the cloud. So service layer, developers use these clouds used to build applications faster. So for example, the developers, so they come up with the modules or software programs. So they go software programs, so they are executed at the service layer. So here the server facilities are provided, and the application interfaces are also provided. So the examples are AWS Lambda, serverless computing. Serverless computing is gaining momentum because you just upload your code, so rest of the things will be taken care by the cloud. So it allocates dynamically the storage required, it allocates the server time dynamically, it allocates other facilities dynamically, and your program is getting executed. You find only the result. So a simple example is that when you upload a PDF file, so that the pages are to be removed, some pages are to be removed, or the merging should be done, so by removing some pages, so you simply upload the uh, PDF file. So whereas the server will identify the pages which are to be removed, and it will once again merge into the single PDF, and it can be downloaded. So this is all done by the server service level. So cloud runtime layer so manages how applications actually run in the cloud. So execution environments, runtime applications such as Java runtime, .NET runtime, Node.js. So these facilities are available with the cloud runtime layer. Then storage layer, so storage layer, you have some files, so where you have to store your databases, files, etc. So in this layer you can store your files, your databases, so your programs, etc. So provides a scalable, reliable, and secure storage. So handles data storage and file systems. Example: Amazon S3, Google Cloud Storage, MongoDB, Atlas. And infrastructure layer, so supplies cloud computing power to upper layers. So basically the foundation is that the physical and virtual servers, they are provided, networking facilities provided, hardware is provided. So simple example is AWS EC2, Google compute engine, Azure virtual machines. And the support functions are the cloud service provider has to provide the security to the data, and the authentication must also be given to the users. So and they have to manage the entire cloud infrastructure. So this is what is the cloud computing architecture. So coming to various types of clouds. So clouds are categorized based on the deployment. Clouds are categorized based on the service model. So when it comes to the deployment, so we have four kinds of deployment models. One is private model, second one is public model, third one is hybrid model, and fourth one is multi-cloud architecture. So I'm going to explain about the different types of clouds based on the deployment. So private cloud, so which is dedicated to a single organization, an organization which deploys the cloud computing facility for its own purposes. So it has total control over, and the security is not an issue because entire thing is managed by the individual, the private organization. So they can do customization, they can the drawbacks are that they have to establish the entire cloud infrastructure, which involves high costs and maintenance. Then comes to the public cloud, so where the cloud infrastructure is provided or established for providing services to the third party persons over the internet. So normally they offer services on typically pay per use model. So especially CPU time, storage, bandwidth, networking, etc. All these things are offered on pay per use model. So the benefits are cost saving to individual or organizations, scalability as much as you can use it. So at the higher capacity or lower capacity, and you don't have to establish an infrastructure, and you don't have to manage at your own premises. So examples: Amazon Web Services, Microsoft Azure, Google Cloud Platform. And hybrid cloud is nothing but combination of private cloud and public cloud. So workloads can shift between environments. Say for example, I have my own private cloud, and I also utilize the public cloud. So the work balance between basing on the requirement of my applications. So this is done using the private cloud and public cloud. So flexibility, cost optimization, some part of the cloud is done by the organization itself is, or maintained by organization itself, is called as private cloud, and we also use the public cloud. Say for example, the programs are deployed at private cloud, whereas databases are stored in public cloud. So from the private cloud, we execute the programs. So these programs take data from the public cloud, and the results are given to the customers, or results are given back to the customers or the organizations. So flexibility is cost optimization, overflow handling. So they are all done in the hybrid cloud. So example, Microsoft Azure hybrid, AWS Outpost, IBM hybrid cloud. And fourth model is multi-cloud architecture. So this is a similar architecture like hybrid cloud. So instead of having private plus public, now here you can have different models like public plus public. So instead of locking to a single cloud service provider, so you are deploying your applications, databases, etc. over different clouds. Say for example, some part of the application is stored in Microsoft Azure, and some part of the application is stored in Amazon Web Services. So both the clouds are utilized simultaneously by the customer or organizations. So these are the four types of clouds based on the deployment models. So next we come to the clouds, types of clouds basing on the cloud service models. So we have the four kinds of services which are offered by the cloud. Such clouds are categorized based on software as a service, platform as a service, infrastructure as a service, function as a service. So first of all, what is infrastructure as a service? So infrastructure as a service, the cloud service provider provides servers, storage, networking over the virtual interface. So users manage operating system, storage and applications by landing at the cloud. So in so it is like the cloud kitchen. So we are arriving with all our ingredients, and all our ingredients, food material. We are reaching the cloud kitchen where we want to cook there. So the server, storage, networking facilities, they're all offered as infrastructure. So examples: AWS EC2, Google Compute Engine, Azure Virtual Machines. Platform as a service. So it provides deployment and development environment. Say for example, the customer wants to develop some software. So for example, he has to develop an e-commerce application. So he can go to the cloud. The platforms are available, so he can develop the application, he can develop the modules, and he can deploy the modules in the real environment. So this support is given as part of platform as a service. So users focus on building newer applications, or maintaining the applications, or modifying the applications, or running the applications, and the cloud service provider manages the infrastructure. So for this, pay as you go is the model that is adopted here. So it frees organizations from software maintenance and resource planning. And examples: Google App Engine, Microsoft Azure App Service, Herald. They are the platforms where the customers can build their applications and they can readily deploy over the cloud. And software as a service, access vendors software on subscription basis. Say for example, we have the video services, such as the video on demand services, such as, so the videos are available readily in the cloud, and on subscription basis these are made available to the customers. So no need of installation of the software. So they are directly running on the software. So vendors manage hardware, middleware, applications, and security. So also called as on-demand or hosted software. So example: Google Gmail, Office 365, Salesforce, Dropbox, etc. So where, so in my desktop system, I don't have Microsoft Office at all, but I use the cloud service I land up in the cloud service where the Microsoft Office related applications are available, and I use them. I type my document, I create my presentation, or I create my database using MS Access, etc. So this is software as a service. So coming to the function as a service, so this is nothing but the serverless computing, where you need to submit only your program to the cloud. Rest of the things will be taken care by the entire cloud infrastructure. So it will execute, it will allocate necessary resources for execution, and the the final execution is done by the cloud. So FAAS is a serverless computing or serverless cloud service that lets you run the code in response to events without managing servers. So you write a function or a program, small piece of code, upload to the cloud. The cloud provider executes it only when it is triggered, and you pay only for the execution time. So using Amazon AWS Lambda, you can do following things. Run a function that resizes images only when a photo is uploaded. So this is one of the examples. So benefits: no server management, automatic scaling, cost efficient, and event driven execution. So coming to the benefits of cloud computing for enterprises as well as individuals. So reduced cost, because so whatever is a utilization, you are going as pay as you go model, which lowers your infrastructure costs and the capital expenses of an enterprise. Scalability: rapidly you can expand your operations or shrink resources as per the demand. Flexibility and collaboration: access data anywhere across the globe, and real-time access of your cloud services by your team members across various locations of all times. Business continuity: reliable backups and disaster recovery, which happens, or recovery ensures resilience. So the whatever data that you are storing, the backups are maintained by the cloud service providers, and the disaster recovery, when in case in the event of disaster or cloud downtime, so the recovery models are also deployed, are readily available in the cloud infrastructure. So cloud competitive edge. So since your investments are less, so your IT overheads are less, you can focus more on innovations and growth of your organization. Accessibility and mobility: work from anywhere, from any device, anytime, with internet access. So some people, for example, Google is providing various kinds of services. So the services can be, say, for example, it is offering a Gmail service. So wherein the customers can use their laptops or desktops or the cell phones or of various capacities of hardware. So whatever is that kind of device, you can use it over the internet. Automatic updates: the cloud service provider will have to provide the automatic updates. So they handle software patches, upgrades, and they also handle the maintenance related activities. So faster time to market: since your cloud is providing most of the facilities, you can rapidly develop your applications modules, and you can quickly enter into the market. So cloud computing, few challenges to the organizations. So security and privacy risks, still there are security and privacy risks. So risk of data breaches despite certifications. So most of the cloud infrastructures, so they do have the certifications, but despite certifications, some security issues because of the hackers. The hackers are finding new ways, new avenues, new strategies to reach the cloud space, and they are uh, they are accessing the cloud in an unauthentic way. So hackers target the cloud storage. So despite number of certifications, so this is still an issue because hackers are always intelligent. So they are coming up with new practices and new approaches. Still, this risk is available. This risk has to be addressed. So downtime and reliability. Suppose if the cloud service provider has some problem in maintaining cloud for a minute or for some time, the provider because of overload or some other issue. So provider overload may cause outages. Applications may become temporarily unavailable. So recently, so this happened with the air traffic management. So most of the applications, so they are deployed in the cloud. So since there was the cloud was down for 1 hour, so the operations at London airport were stalled for almost 2 to 3 hours. So similarly, the internet dependency. So every service, every application, every database, things are stored in cloud. We are relying on cloud, but we don't have proper internet facility, or our internet to access the cloud is not reliable. So in such a case, it is an issue. So we should have strong internet connectivity or reliable internet connectivity. Public Wi-Fi increases vulnerability because the hackers may enter into your cloud space. So cost management and financial commitment. So since we are adopting pay as you go model, sometimes we may exceed utilization of the cloud, and which is beyond your budget. So and risks of overspending without monitoring. And vendor lock-in. Suppose I have a locker in Union Bank of India. So most of my valuable things are stored in the locker of in Union Bank. So I lock to that. I lock to the bank. So instead of migrating to a different bank. So similarly, one cloud is providing opportunity or the services. So the customers, for them to migrate to a different vendor, so because a different vendor is maybe providing higher uh, higher facilities or more facilities, better facilities. In such a case, since our deployment migrating from one cloud to another cloud becomes a difficult task. So limited control. So providers or cloud service providers, since they manage the infrastructure, so restricting users access. They are restricting users access. So user has to enter into the cloud space with the proper credentials. So backend tasks like firmware updates are not available. So whatever the backend updates, so they are not readily available to the enterprises. So performance and latency. Sometimes latency is causing delays in accessing the cloud. So especially some applications like finance and healthcare, where the delays are not expected. So these are the challenges over the cloud computing. So applications of cloud computing. So what not most of the industries. So they are utilizing the cloud services. So example, I just explain some applications. So education sector, the Coursera or uh, Coursera or some platform like this. So they are offering most of their courseware in the cloud, and online learning facilities, online learning platforms are established using cloud, and the students are the persons who want to utilize the Coursera or its material or examinations. So they're all done using the cloud services. So delivery of the content and the conduction of examination all done from the cloud. So millions of students and faculty members, they are accessing the certification programs like Coursera, edX, and all. So second application is business models for customer relationship and management. So especially Salesforce to manage various customers and the relationship with the company. So that is across the globe. Then healthcare, so store the healthcare records, the analysis of patient data, telemedicine services, etc. They're all available over the cloud. So I just read out some more applications like AI and machine learning. So AWS and Azure, they provide GPU resources for training the AI, ML models. Then Internet of Things. So for example, smartphones, smart homes, connected cars, industrial automation, etc., all are happening with the help of the Internet of Things. Then entertainment and media. So in future what happens is that most of the devices, most of the uh, items which are managed at home, so they are all connected to cloud. So the cloud manages every operation at home, so without physically or manually operating the things right now. For example, the fridge, micro oven, the stove, the electrical stove, so then the washing machine, etc., AC, air conditioner. So like this, number of things can be managed using the cloud services. So the data can be processed in the cloud. So and entertainment and media, Netflix, Spotify, so since they have huge number of the audio and video files, so they can be accessed over the cloud. So like this, software development as testing, so big data analytics, e-governance, banking and finance, retail and e-commerce, gaming, communication and collaboration. So such as Zoom is one of the applications where the cloud services are utilized. So right now the session is going on. The recording of this session is stored in the cloud. So disaster recovery and backup, then scientific research, supply chain logistics, etc. So these are only the few limited cloud computing applications. So coming to the recent trends, or what are the upcoming trends in cloud computing? So the public cloud is growing a lot. So instead of private cloud, so more and more vendors are providing public cloud, because the third party organizations such as small and medium enterprises, the individuals, they are deploying their applications in the public clouds. So post pandemic, the spending has increased to 18.4% on utilizing the public clouds. So the leading types of architectures are SaaS is leading, PaaS is fastest growing, and so these are of course accessed by small and medium business concerns. So multi-cloud and hybrid, so which I explained in the previous slides. So because of outages, or because of cloud shutdown, or because of some issues with the cloud downtime, so people are relying on multi-clouds or hybrid clouds. Multi-clouds are nothing but utilizing two public clouds simultaneously, or hybrid is nothing but private and public simultaneously. So this improves resilience, then avoids a single provider risk. So containers is one of the concepts, advanced concepts in cloud computing, where the application, so with the dependencies, application and dependencies both are managed using the application, using the environment. So they are portable, secure application environments, supports development operations, DevOps, continuous integration, continuous deployment. So continuous integration, you have developed a new container, so that can be integrated with the existing software, and deployment can be done, so that the customers realize the presence of a newer facility. So cost efficient and orchestration or Kubernetes. Kubernetes dominates the container orchestration. So which is nothing, orchestration is nothing but automation of scaling, load balancing, healing, and service management of different containers. Virtual desktops. So cloud provides few partial space of the storage, software, operating system, databases, etc. So that can be utilized as virtual desktop. So they are scalable, they are secure, low cost, and remote workstations. You can use as remote workstations. So cloud native security, so which is nothing but edge first cyber security focus, or unified security across SaaS, data centers, and devices. So collaboration platforms such as Cloud enables global teamwork, customer engagement across the globe, and serverless adoption. So these days, the serverless computing is growing, where you need to provide only the code. So remaining deployments, remaining aspects are taken care by the cloud. So the healthcare, government, and MSPs using paper execution. So you are going to the cloud only with the code. So it will allocate required facilities, resources, and the code is executed, and readily the services are given to the customers. So cost optimization, around 30% of the budget is saved because of the cloud. So dedicated financial applications and operations monitoring tools, so which are needed, and AI plus cloud convergence. So these days, AI is emerging, AI deployments are happening, and enables ML training, machine learning training, real-time analytics. So since machine learning, so this is becoming part of the cloud, and artificial intelligence. So real-time analytics are possible. So Azure versus AWS. So the Azure is taking momentum over AWS. It is narrowing the gap between the AWS and Azure. So monopolizing is minimized. It is coming down. Big enterprises contracts so are in play with the Azure. So coming to the emerging trends once again, in essence, AI-driven automation for cloud management and cloud optimization, edge computing for low latency real-time data processing. So I have already told about edge computing. Edge computing is nothing but some part of the application is processed locally, and the remaining part is deployed in the cloud. Say for example, IoT devices. I explained about air quality index of different cities. So the local IoT devices they process here. So serverless computing, which I explained. So you are just going with the code, and it is getting executed by the cloud. So quantum computing, so integration of quantum computing is nothing but parallel computing of higher order. So where numerous calculations have to be simultaneously carried out. Say for example, IBM is going to establish 156 qubit quantum computing in Amravati Quantum Valley, wherein the number of computations simultaneously possible are 2 power 156. 2 power 156 is a greater number. So that many calculations, that many computations simultaneously can happen with the cloud computing. So say for example, so we have to analyze large number of items. So with the help of quantum computing, we can analyze in few seconds or few minutes. Say for example, we have a great number of YouTube videos. Out of all YouTube videos, so find out the health precautions or health guidelines to manage the hypertension or the diabetes. So like the quantum computing, so they go across various the videos, and then audio files, and analyze, and they give the essence to the customer in few seconds or few minutes. So that is the capability of quantum computing, so which is also deployed in the cloud. So enhanced cloud security. So cloud security is enhanced with the zero trust model. Zero trust model is, so nothing can be spared, so we have to doubt everyone or every click. So green computing, which initiates sustainable energy efficient data centers. So whereas the power saving is the basic motto, basing on the power saving, the load balancing, and uh, so things are happening in the green cloud. So generative AI integration. So for accessible scalable AI solutions. So say for example, the ChatGPT, etc. So they are deployed in the cloud models. So where the generative AI, so the data sets, whatever, so they are available readily in the cloud. So their applications utilize the data sets, and they generate the content as per the customer requirement. So multi-cloud, different clouds can be used. simultaneously, so that one cloud is at down, the other cloud can be operated. So this is a best strategy or hybrid strategy for resilience and flexibility. So IoT empowered AI applications, smarter automation. So that is happening. So weather forecasting can be done with the help of IoT based or IoT based AI applications. Cloud native development. So developments, the software development is done with the help of is done in the cloud infrastructure. So coming to the advanced architectures and future trends of cloud computing. So first of all, let me discuss about some ingredients of advanced computing. So the first ingredient is monolithic system. Second ingredient is microservices systems. So what are monolithic systems? Monolithic systems are the so these systems. One second. So monolithic systems are the systems where the various modules are executed together. Say, for example, we have the front end and back end, both are executed together, then only the application is coming to a reality. So these kinds of application is called as monolithic systems. So monolithic systems do have multiple user interfaces, multiple databases, multiple software programs, etc. All are interdependent and they are executed together as a single program, and the services are obtained. So in monolithic, whereas in the microservices, so instead of having a number of modules, number of the models, so each service, each application or each module is providing a specific service, so they are executed independently without touching to the others. So this is called as microservices. So monolithic services are where the software programs, databases, user interfaces, etc. They are all coupled together in a one second. So in the microservices, the modules, instead of handling the entire software as a single model, so here modularization or different aspects are identified as a single different modules, and they are independently executed, so without depending on the others. Say, for example, catalog services, shopping cart, discount, ordering. So these are all the services which are offered in, say, Amazon or Flipkart. So they are independently executed without depending on to each other. But in the case of monolithic, a single software is handling all the things together. So monolithics are tightly coupled. They are harder to scale up or scale down, whereas microservices, they are loosely coupled and cloud friendly, and they are scalable. So key components here to implement these monolithic and microservices are containers, orchestration, and serverless computing. And the benefits are resilience, then scalability and faster deployment. So coming to monolithic systems and microservice applications. So monolithic systems, a single tightly coupled application where all modules such as user interfaces, business logic, databases, etc., they are all bundled together. So in the case of microservices, an application is broken down into small independent services. So basing on the function or modules, so each is handled for a specific business purpose or specific business capacity. So drawbacks of monolithic systems are they are very rigid because all are bundled together as a single application. So the limited scalability, suppose you want more storage. So once again, the entire module, entire application has to consider enhancing the capability in the cloud, and must scale the entire application as one unit. So even if one feature needs more resources, so slower deployments, is one small change is affecting many parts of the entire application in the monolithic systems. Whereas in the case of the microservices, they are scalable. So whatever is the application part, you can enhance. So only that part you are executing, and resources are allocated as per the need. So flexibility is there, faster deployment, because each service you are handling independently, each service you are deploying, each service you are developing. So teams can do simultaneously more number of application developments they can deploy simultaneously, so that the project is becoming very fast to the market. Resilience, failure in one microservice doesn't affect the whole system. So whereas in the monolithic system, failure in database will stall the entire application. So examples of monolithic systems are an e-commerce application where product catalogs are available, payment modules are available, user logins, all run in a single code base. Whereas in the microservices, different services work in different modules. So the same e-commerce application, but product service model so is running as single application. Payment service is another application. User services, payment modules, etc. So they run independently. So once again, the monolithic architecture and microservice architecture. So code base is single and a unified code base in monolithic, whereas in microservices, the code we have the independent modules or modularization of the services. Modularization of the services. So basing on the service, the modules can be prepared. So coupling, so the things are tightly coupled. The software programs units are tightly coupled. So whereas here the loosely coupled, because each service or each service can be developed independently, and they can be modified at any point of time. So scalability. So here scalability is a difficult issue in monolithic, and in the microservices, scalability is not an issue at all. So development complexity, simple to develop initially in monolithic, but here in the microservices, more complex to develop the programs. So maintenance challenges are there in monolithic, but maintenance becomes easier in microservices. So why to shift to microservices? So microservices, since they are better than the monolithic services, because of the scalability, because of the flexibility, because of the release resilience, because of faster deployment, because of cloud synergy. So we have to shift to the microservices. So challenges in transition. So while transiting from uh, monolithic to the services, microservices. So the complexity, managing distributed systems, so data consistency, monitoring, so observing the entire cloud, and inter-service communication, cultural shift. Cultural shift is nothing but so DevOps teams of various DevOps teams and their adaptability, so which is a challenge. So complexity in managing distributed systems. So data consistency across uh, different modules, different services. So monitoring what is happening in one service and all. Then inter-service communication and cultural shift, operations of different teams of different services. Say for example, the Amazon is offering various kinds of services. So it is e-commerce portal is having the cataloging service, then the basket service and the payment service and delivery service, etc. So these services are independent, so but they have the complexity in handling. So since they are distributed, these services are distributed, and data consistency has to be taken care of by all these services, monitoring what is happening in one place, so whether payment has been done or not. So the next module, next service has to properly identify it. So like this. So another important ingredient in advanced computing, advanced cloud computing is containers. So container is nothing but your application plus dependencies. So they are the lightweight applications. They are in the isolated environments that that are coupled with their dependencies. Say for example, the graphic user interface, GUI is having dependency of a database. So both are dependent. Or a huge software program that requires the math library support. So in such a case, the dependency is math library support. So the dependencies plus applications both are deployed together, both are configured together, becomes a container. So key features are that so portable across different environments. So they are faster than traditional virtual machines, efficient resource utilization. So the tools available for doing the containerization are Docker, Podman, Kubernetes. So use case is that running microservices with container environments. So here you can see in the down there is a picture so of container. So there is one application with the bins or libraries. There is another application with bins or libraries. So each application is configured with their dependencies. Here there are two applications, they are configured. So there are two containers. So these containers are handled so by the container engine. And coming to the containers versus virtual machines, so we talked about virtual machine. So virtualization was initially done, so wherein a huge mainframe computer, so it can spare some part of storage, some part of CPU time, some space of the storage, some part of the software, so some part of the operating system. So here the hypervisor will create the virtual environment, virtual machine. Hypervisor is a package, is a software which will create the required size of virtual machine in the virtualization. So here the user lands here utilizing the virtual machines basing on the requirement. This is one model which was prior to the cloud computing. So but now the containers, so they are managed with the help of container engine. So coming to the differences, as told many times, so virtualization in the case of containers, operating system level virtualization is operating system level virtualization, and virtual machines in the case of hardware level virtualization. So this is happening. So in the containers, OS level virtualization; in the virtual machines, hardware level virtualization. Resources, lightweight, no full operating system, highly efficient. So they run more applications at the same time. So in the virtual machines, heavy machines, each virtual machine needs some part of operating system and virtual environment. So startup time very fast, so you can quickly access to the containers or deploy the container, whereas virtual machine creation itself is taking some time, so it is slower than the containers. So portability, highly portable because it runs consistently on any system with a container engine, whereas virtual machine less portable. Once the virtual machine disappears, your environment also disappears. Isolation, process level isolation in the containers, whereas virtual machine strong isolation. Each virtual machine has its own operating system and other supporting services. So use cases, microservices. So with the help of containers, microservices, cloud native applications, continuous integration, continuous deployment pipelines. Whereas virtual machines, legacy applications running multiple operating systems, strong security, isolation, etc. So coming to the hypervisor, in the case of the virtual machines, so the hypervisor versus container engine. So hypervisor will create the virtual machines by sparing the computational resources to specific virtual machines, whereas container engine so will only handle the containers, so where the serverless computing is possible. So hypervisor, you can see, so software, so that allows multiple virtual machines, software that allows multiple virtual machines to run on a single physical machine. So how it works, each virtual machine has its own operating system and applications. The hypervisor sits on top of hardware and allocates resources to each virtual machine based on the need and requirement of the user. So examples, virtual machine where ESXi, Microsoft Hyper-V, KVM are the examples. So running multiple different operating system environments on the same hardware is possible. So because the hypervisor can create the virtual environment, virtual machine for basing on the Windows, and virtual machine basing on the Linux virtual machine. So here one more concept is Docker. So Docker is nothing but handling multiple containers. Handling multiple containers. So that is done by the Docker. So Docker is a containerization platform that packages an application with all its dependencies into container. So how it works? Containers share the host OS kernel, unlike virtual machines which need a separate operating system. So they are lightweight, they start in few seconds, use fewer resources. Examples, Docker engine, Podman are the software programs. Best for running so microservices and cloud native applications. So here you can see Docker. So the Docker can identify different different containers. So Docker is taking a few containers, and these containers are executed. So the required computational facilities are scaled up as per the requirement, are scaled down, they are load balanced, etc. So containers and Dockers. So lightweight, portable virtual environments. Docker is a tool for building, shipping, and running containers. So advantages: consistency across development, testing, and production, and resource efficiency. Example: Docker Compose for multi container applications. So in the right side we have down one Docker. So this Docker is handling multiple containers. So these containers, so Docker is a tool to build multiple containers, shipping them, or running the containers, and deploy the services. So orchestration is another ingredient in advanced computing. So which is nothing but automated management, deployment, and scaling of containers. So automated management, deployment, and scaling of containers is multiple containers is called as orchestration. So it coordinates multiple containers, handles load balancing and failover, automates scaling and updates. So examples: Kubernetes and Docker Swarm. So these are the programs. Use case: managing complex microservices and deployments. So serverless computing is another concept where which is emerging in the cloud computing. So serverless is which is nothing but in the options of server at the at the enterprise or the customer. So you're landing the cloud with the cloud with the code or a program. So write a program or write a code. So go to the cloud, submit it to the cloud, and execute the program, get the services. So pay only when it runs. So this is the model of serverless computing, a cloud execution model where the provider manages servers automatically. The developers focus only writing code, not server operations. So code runs in stateless compute containers triggered by the events. Event is nothing but file uploading. Say for example, the MS Word file has to be converted into PDF file. So the moment the trigger happens or a call has been given to the cloud, so the file goes to the cloud, where the cloud service, the server converts the MS Word file into a PDF file. So and fully managed by the cloud provider. So the cloud provider fully manages the entire serverless computational facility. So the examples are AWS Lambda, Azure Functions, Google Cloud Functions. No need to handle provisioning, scaling, maintenance, etc. So serverless computing, so it is event driven. The moment you upload file, so the program gets executed. No server management at the host premises. So examples: AWS Lambda, Azure Functions, Google Cloud Run. So advantages: auto scaling, pay per use. Disadvantages: cold starts. It takes some time to right from the setting up to the program execution takes some time. So vendor lock-in. So you are locked to a specific vendor where the migration may not be possible. So containers versus orchestration versus serverless. So this was explained many times. So I just want to skip down this. So another concept called as Kubernetes. So orchestration can be done with the help of a package called Kubernetes. So Kubernetes is normally called as K8s, open source container orchestrator. So features are auto scaling, load balancing, self healing. So components are pods, nodes, clusters, deployments, and providers: Google Kubernetes Engine and Amazon EKS. So these are the providers. So cloud security fundamentals. So we have the security threats once again in the cloud. So since an organization relies on the cloud infrastructure, it manages entire data or databases in the cloud. So data breach may happen because the hacker may enter into the cloud infrastructure or data storage of a specific enterprise, and the data may be spoiled by the hacker. And DDoS, distributed denial of service, that may happen because the cloud may not be given as access to the right customer or the organization. So denial of service happens when the hacker floods millions of packets to the destination, to the cloud, where the cloud is engaged in understanding each and every packet each and every packet. So that whereas the genuine customer will not be in a position to, because of the heavy load, the genuine customer may not be in a position to access the cloud at appropriate times. So there are threats once again because of these two security issues. Then best practices are that encrypt everything in the cloud. So whatever the data that you are storing, encrypt and store there. Even the hacker enters by chance, so the data may not be available, may not be visible, and hence you cannot do anything with the encrypted data. So access control, give strict access control with a zero trust policy. Whoever is the customer, whoever is the organization, so they have to necessarily go through the security checks and with appropriate credentials. So only the cloud access should be possible. So shared responsibility model. So once again, the responsibility lies on various users. Say for example, the Amazon e-commerce portal. There are numerous customers, so they are available across the globe. So and developers, there are developers, so sitting at different offices, different cities across the globe. So it is the shared responsibility of securing the cloud. Uh, and security is shared. Providers handle physical and user management applications or data. Their encryption services are provided. at the resting places or transit places. Transit is nothing but when you are accessing data from the cloud storage. So data is moving from cloud to your desktop system. So in such a case, during transit, data has to be secured. So most of the times, so right now, advanced encryption standard 256 is adopted for the REST models as well as transit models. So identity and access management policies to control or restrict the access of various users. So there was a breach to move it in 2023 by the hackers, where the hackers have really entered into the move it cloud. So advanced security, that is zero trust policy. Zero trust is nothing but verifying everything, assume the breach. So pillars, identity verification, least privilege, micro segmentation. So tools, Okta and Beyond Corp, implementation, MFA, network segment, etc. Traditional parameters are obstacle, zero trust checks. Every request has to be done with a zero trust check. Use JWT for authorization, segment networks with VPC, things like that. So Google's Beyond Corp is a pioneer in the advanced security with respect to zero trust. Integration with cloud native tools. So emerging trends in edge computing, as I said, edge computing. So some process is done at the data source, especially IoT devices. They are doing some processing at their device level, and the processor data is only submitted to the cloud. So in a way that the processing is shared between the cloud and the local infrastructure. So benefits are low latency, bandwidth saving. So instead of uploading every parameter to the cloud, processing there, some part of the processing is done locally, and only the required some required data is stored in the cloud. So examples: AWS, Greengrass, Azure Edge. Edge moves compute closer to users, vital for AR and VR are autonomous cars. Augmented reality and virtual reality are autonomous cars. So reduces round trip to central cloud. So round trip is nothing but you are submitting data and data is processed and data is coming, refined data or the results are coming back to the customer. So the round trips are once again, so they are avoided. So fog is an intermediate layer between edge computing and cloud computing. So use hierarchical processing of smart cities. So wherein the traffic management that is handled with the help of fog computing. So challenges: security at distributed nodes. Then fog aggregates edge data before cloud upload. So this is an intermediate layer uh, where the processed data which is submitted by the edge computing. So the fog layer takes care of the interface between the cloud and the edge computing. So ideal for real-time applications like traffic management. So quantum cloud computing. So quantum is super fast computing. So where complex operations, so they are done simultaneously. So provider IBM Quantum and AWS bracket. So current state hybrid classical quantum systems are available. Quantum usage uses qubits for parallelism. So in the previous slide, I told that so the IBM quantum machine of 156 qubit can handle 2 power 156 parallel computations. So cloud access via APIs solve drug discovery and faster. Still, it is in the growing stage, which has not completely integrated with the cloud computing. But so future is the quantum computing. Sustainable cloud or green cloud, which is nothing but so carbon neutral data centers, where data centers are not consuming much of the power, so thereby saving the carbon footprints. So tools: AWS carbon footprint, Google cloud matching. So impact is reduce energy usage, so with the efficient algorithms. So cloud providers aim for net zero by 2030. So optimize workloads to lower emissions. So use cases for cloud AI, so artificial intelligence, so that is deployed readily as a service in the cloud. Say for example, you are viewing one particular video, the cloud is suggesting few other related videos. So advanced data management databases are deployed in the cloud, and especially the SQL, NoSQL, uh, DynamoDB. So these are available in the cloud. So maintaining data lakes or warehouses, scalability, sharing, and replication. So, so these services are available with the advanced data management. So big data in the cloud. So since databases contain huge amounts of data sets, you can process it using different applications like Hadoop, Spark, Storage, S3, BigQuery, etc. So you can do a lot of analytics using the cloud. So cloud analytics for business intelligence. So we have the tools like Tableau on cloud, Power BI on cloud. So these tools, so they give the business intelligence or the kind of the visualization of various models, various data sets. So AI and ML in cloud, since it takes the machine learning it is accepting the machine learning platforms as in terms of AWS SageMaker, Google Vertex AI. So benefits are that managed infrastructure, pre-built models. Machine learning models are readily available with AWS SageMaker, Google Vertex AI. So workflow, you need to submit the data sets and train the model and deploy the machine learning model. So cloud democratization of AI, SageMaker, etc. and advanced ML features. AutoML is one of the aspects, newer aspects which is coming up with the cloud. So federated learning and ML ops, continuous integration, continuous deployment models with uh, Kubeflows. So auto ML tunes hyperparameters automatically. Federated keeps data local for privacy, etc. And these are the some of the case studies where Netflix on Amazon Web Services. So personalization of the content. If one person wants the health related health related the videos, so it will personalize the videos based on the requirement of the customer. So there are subscriptions which are going and growing, and there are 1,000 plus microservices which are available with Netflix. So this is another Spotify is which is once again providing audio files. So basing on the interest of the customer, so audio files are identified automatically. Kubernetes, BigQuery for analytics, they are all deployed here. And healthcare with Azure, healthcare services are available with Mayo Clinic, AI for diagnostics, etc. So they are all available with healthcare with Azure. So challenges in advanced computing. So cost overruns. Sometimes you may overuse you may overuse the cloud infrastructure. So if there is no monitoring, so then the cost is becoming more. So complexity, skill gap is there still, vendor lock-in. So you are locking to a specific vendor. The skills required to advance the cloud computing, still the skills are necessary skills are the gap in the industry. So security risks, evolving threats are going to evolve every time and anytime. Advanced cloud computing brings power, but there are also some pitfalls, disadvantages. So use financial operations for cost control and one has to use this, train teams on certifications like AWS certified architect, because so these skills are scarcely available. So best practices for implementation: adopt DevOps, continuous integration, continuous deployment with Jenkins, GitHub Actions, monitor Prometheus and CloudWatch, optimize auto-scaling, reserved instances, implement gradually, start with non-critical applications, and monitor KPI like latency and cost. So future of cloud computing predictions. So AI is everywhere and zero touch automation is going to come. Growth, market to grow to $1 trillion by 2030. Advice is that stay updated with certifications. Cloud will integrate deeper with AI and quantum computing. Focus on lifelong learning. So this is what is the advice to all the participants. So that's all from my side. So if any questions are there, I would like to answer. I'm sorry for exceeding my time.
Participants, if you are having any queries, you can post in the chat box.
So I was actually rushing through the content because a lot of content I have to cover in just 1.5 hour session. So some slides I simply skipped. Anyway, if you want the PowerPoint presentation, I can pass it on to you.
Samrat sir? Samrat sir? Samrat sir?
Sir, yes, sir. I'm waiting for Roja ma'am to conclude the session, sir. Madam, are you there in the
Madam,
meet?
are you there?
Sir, yes, sir. I was just
Yes, madam, you
waiting.
can
Yeah.
conclude. Please conclude.
Okay, sir. On behalf of the Department of Computer Science and the participants of the AICTE ATAL Faculty Development Programs, we extend our heartfelt gratitude to you for delivering an insightful and enriching session on cloud computing. Your session was highly informative and exceptionally well structured. The clarity with which you explained key cloud concepts, architecture, applications, latest trends, advanced cloud concepts, serverless computing, cloud security threats and challenges, cloud with AI, case studies, and future of clouds greatly enhance the learning experience of all participants. We sincerely appreciate the time and effort you invested in sharing your knowledge, sir. We truly value your contribution and look forward to continued association and future collaboration. Once again, thank you, sir.
So thank you, madam. Thank you very much for giving me the opportunity. I thank the organizers once again for giving me the opportunity.
Now we are concluding the session, sir. Thank you for all for attending the session.
Okay. Okay. Thank you, sir. So I'm leaving.
Yes, sir.
Those who ever have filled your feedback forms can leave the meet.